So if you recall, last time, actually, when we were talking about these processes, we start by introducing you to moving average process. Then comes autoregressive process. Then later we combine the two to becomes ARMA. Okay. So today we are going to just include another part which is called seasonality to becomes SARMA. Okay. Then later we are going to consider those that are not stationary. In other words, you have to differentiate them. By so doing, you are going to add another integral part called differencing. Then it becomes ARMA, now becomes ARIMA. Then from that ARIMA, we just put another part which is called seasonal, and then becomes SARIMA. So it's from moving average, autoregressive process, ARMA, then SARMA, then ARIMA, then SARIMA. So you have to have a link of those processes. You have to follow them. So now let's just go to the screen. Okay. Okay. So this is lecture number 15, if I recall. So we are going to introduce ARMA. Okay. So it's lecture number 15. Let me just indicate here. Lecture 15. And it's about SARMA process. Okay. It's about SARMA process. Now, let me just take you back. Let's start from ARMA process because we've dealt with that one before, so that you can see the connection between ARMA and SARMA. So if you recall, ARMA process actually is ARMA of order PQ. In other words, it's autoregressive of order P and a moving average of order Q. So how do you write this? ARMA PQ. It's written as phi because autoregressive process we represented them by phi P for the general, then B xt. Okay, on the left hand side. On the right hand side, we are going to have theta because the moving average process is represented by parameter theta. Theta what? Theta q. Why? Because we're generalizing it. Then B Z T. And again, here ZT is a white noise, which means 0 and variance sigma squared Z. Now, this is our ARMA PQ process. And remember, we just want to introduce ARMA process in this regard. So, ARMA process, as you know, is defined by phi PB xt, which is equal to theta QB ZT, where phi P, where phi PB is equal to 1 minus by 1b minus by 2b squared minus, and so on. Okay, and theta q b is equal to 1 minus theta 1b minus theta 2b squared minus theta 3b cubed minus theta 4b to the power 4, and so on. Okay, this is our ARMA process. Now, let me just call this equation number 1 so that you can follow it. Then from equation number 1, which is ARMA process, we can add another part there. From ARMA PQ, we can just add, remember, you have got phi P B, okay? So we can add another part called phi, but this time around is a capital letter phi, and then capital letter capital letter P, and then capital letter B to the power S, okay? Then xt equal to. Do you see the part that I've included there? This is the part that I've included there. So it's capital letter phi P, and P is a capital letter as well. Then B to the power S. Next, yes.
Yeah, I want to ask a question here, sir, on the theta QB, which is from the moving average, you know.
Yes.
It's not a plus there.
No, you can just put a plus. You mean, let me show you. You mean here, isn't it?
Yes, sir.
It depends. You can put plus, it's fine. Or you can put a minus, it's fine. That is why I said from the time series processes, plus and minus are the same thing. There's no difference on that. But we are using minus. We just thought maybe we just take another process where we have got a minus sign. Okay. So in your case, if you put plus there, you take a moving average process with a positive sign. So there's no problem on that. It's just the sign. It doesn't change anything. It doesn't change the order of a moving average. It doesn't change the process. It's only the signs. So you can use plus, you can use minus. It doesn't matter. Are we together?
Sir.
Okay.
Good morning, sir. Can you please explain again from where you started?
I'm saying today we're going to introduce a new process called SARMA. It's SARMA because we're going to include the seasonal part on that particular process. Remember, we have already done with the ARMA process, which is the one that I showed you there for equation number 1, where phi p is equal to that and theta qb is equal to that. So now, from equation number 1 there, which is our ARMA process, we can add another part, which is this one. And we call it a seasonal part. That is why it's having b to the power s. That s represents the seasonality. So that is why the whole part here being added is a seasonal part. And this one is a non-seasonal part because it doesn't have an s. So this other one is called a seasonal part because it's having an s on top. So this is the part that we have introduced there. So the same applies to the right-hand side for the moving average. We have a non-seasonal part, which is this one. So we just want to add the seasonal part as well. So how do we do that? So we are going to have theta q b which is a non-seasonal part, or which is a non-seasonal moving average. Okay, so we just want to add a seasonal moving average. So how do we do that? We have a capital letter theta. How do you write the capital letter theta? It's like 0 with a hash inside. Okay, that is a capital letter theta. Then capital letter Q. Okay, then B to the power S, because it's seasonality. Then include ZT there. And again, this part is a seasonal part for the moving average. And this other one is a seasonal part for autoregressive. So all in all, it changes our ARMA PQ, this one. It changes that ARMA PQ to become SARMA. So in other words, now we are going to have SARMA.
Sir,
Yes.
is the P and the Q at the bottom, are they capital letters?
For the seasonalities are supposed to be capital letters, so that you can differentiate them from the non-seasonal part. For this, yes, it's like that. So now becomes SARMA. SARMA of order what? Of order PQ. So PQ is the one that we have on top there. So we have to add another seasonal part now, which is what? Capital letter P. And then capital letter Q. So because it's a seasonal part of both autoregressive and moving average, you have to add S. Yes.
Sir,
Yes.
can
Yes,
you
yes.
please explain this part here from 1, the signs?
Or the where this from step number 2 and 3.
This pattern from 1, this new signs.
Oh, from 1. Okay, I see that. Okay. I was saying, is in that we have got a ARMA process, which is equation number 1. So from that equation number 1, which is our ARMA process, we can add a seasonal part for both autoregressive and a moving average processes. So in other words, you have to add a seasonal part in autoregressive, which is a left-hand side. Okay, which is this one. This is the seasonal part in the left-hand side, and it represents what? The seasonal part of an autoregressive process. Okay, so we do the same on the right-hand side. You add the seasonal part for the moving average, which is this one. So this is the seasonal part. Both those seasonal parts, they were not there before, isn't it? So we included them now so that the process can change to be SARMA process, because it was ARMA at the beginning. Then we included those seasonal parts from both autoregressive and moving average to become SARMA. So that's why here at the end we are having SARMA of PQ. This PQ is the order of non-seasonal autoregressive and a moving average, which is the one that we are having up there. So, but the other part is a
Sir,
yes.
sorry, sir. Is this sign on the left hand side of from 1? Is it hashtag inside a circle?
Yes, yes. It's called a capital letter theta.
Okay. Thank you, sir.
Okay, it's fine.
So
So now, yes.
this is not part that we are adding minimum. Where are we getting them from? Because if you can check when we're dealing with the market, we join the moving average and the autoregressive. So now on this one of SAMA, when we're adding this part, where are we getting them from? Did we do them somewhere or?
No, Immediately when you deal with the seasonality, you still remember that we talked about seasonality before. I said S stands for seasonality, where it can be represented by 4 or it can be represented by 12. If it is represented by 4, what did I say? I said that we are dealing with the quarterly data. But if S is represented by 12, so we are dealing with the what? The monthly data. So that S is either representing the quarterly data or the monthly data. So that is why we are having it there. So in each and every data, it's either you have the seasonal part or no seasonal part. So in case where we have the seasonal part, so we have to include S there. So that is why I said those parts are seasonalities, both of them. So we have to include them.
Oh, now I get it. Thanks, sir.
Okay. So
Please,
please, there is somebody who unmute the thing there. Let me see. Says, can somebody finish the mic? Are we together? Can you mute your mic? Okay, thank you very much. So now we have got Sarma PQ PQ. So the question is, this Sarma PQ PQ is representing the backshift operator up there. This one, this equation. So this is Sarma PQ PQ. In other words, you must know that if you have been given this equation star, here you must be able to come up with this one. Okay. And again, if you are given this Sarma PQ PQ, you must be able to go back to equation star. That is the main idea. Okay. So the parts that we have included there, which are our seasonalities for both autoregressive and a moving average, it can be written as, in this case, you can say where, oh, sorry, where the seasonal part of an autoregressive, which is phi, capital letter P, capital letter B, to the power S, is equal to 1 minus capital letter phi 1 B to the power S minus capital letter phi 2 B to the power 2S minus capital letter phi 3 B to the power 3S, and so on, like that. You see that? The same applies to that other seasonal part for a moving average. So you have got a theta, capital letter theta, Q, B to the power S is equal to 1 minus capital letter theta, 1 B to the power S minus capital letter theta, 2 B to the power 2S minus capital letter theta, 3 B to the power 3S, and so on. All together. So it represents that one. Okay. So for argument's sake, let's say your P, or small letter p, which represents the order of a moving average in a non-seasonal part, is equal to 0. And another P, which is a seasonal part for the same autoregressive process, is equal to 1. And Q, which represent the order of a moving average in a non-seasonal part is equal to 1, and the capital letter Q, which represents the order of a moving average in a seasonal part, is equal to 1, and our S is equal to 12. In other words, we are considering the monthly data here. So what are we going to get? Okay, let's apply that scenario. Can I go to the next page, please?
Yes, sir.
Okay. So now, what
No,
I'm
wait.
saying is,
No, wait, sir.
okay. So we have P equal to 0, capital letter P equal to 1, Q equal to 1, capital letter Q equal to 1, and our S equal to 12. So we just want to see what are we going to get, how the process is going to be look like. Are you done?
Yes, you can move.
Okay, thanks. What I'm saying is we are having P, which is equal to 0, and big P, which is equal to, let's say, 1, Q equal to 1, capital letter Q equal to 1, and then S, which is a seasonal, equal to 12. So that means we just want to see SARMA So the order of a autoregressive part in non-seasonal is 0, isn't it? And the order of a moving average part in non-seasonal is 1. So that means we are going to have something like that. And the order of autoregressive in a seasonal part is 1. And the order of a moving average in a seasonal part is 1. And then our S is 12. That's what we're saying. So we're going to have SARMA 0, 1, 1, 1. So in other books, they don't write SARMA. Instead, they can write it in this way. Or they can write ARMA 0, 1, 1, 1, then 12. Can you see the difference? The first one is having S, which is called SARMA, and the next one is it doesn't have S, but it included the seasonality, which is 12 there. As long as we have this 12 there, so it's ARMA process. Even though you wrote it as ARMA 0, 1, 1, 1. So and we are having this other part there, which is a seasonal part. It shows that we are dealing with the seasonality. So they're the same. Both this one, SARMA and ARMA of this one, they are the same. There's no difference there. Because sometimes you can find that in other books, they use SARMA 0, 1, 1, 1, 12. Other books use ARMA 0, 1, 1, 1, 12. It's the same thing. Are we together? So now, we just want to write this one in backshift operator like we did before. So remember, this 0 here, it just tells us that we don't have an autoregressive process in the non-seasonal part. It's not there. Okay, so that means for SARMA, the general one is like this, if you still recall. PQ, PQ, then S. Okay, here is 0, so we don't have it. The rest is 1, 1, 1, 1, 1. And it's defined this one, SARMA is defined by phi P, the general one, B, okay, capital letter phi, capital letter P, B to the power S, then xt, which is equal to theta q b capital letter theta capital letter q b to the power s, then zt. This is the general one for Sarma process, okay? So, but if they say p equal to 0, capital letter p1, small letter q1, capital letter q1, and s12. So, for p equal to 0, it simply means that we don't have this part, this one. It's not there, okay? That part is not there. But coming to this one, our p is equal to 1. Here p is equal to 1. Okay? And here s equal to 12. Okay? And here small q equal to 1. And then capital letter q equal to 1. And then s equal to 12. You see that? So how do you write it nice properly? So you are going to have, this implies that you are going to have phi, capital letter phi 1, b to the power 12, xt on the left hand side. Are we together? On the left hand side, because we don't have phi p b, because it's not there, because p is 0. So that is why we are using capital letter phi 1 b to the power 12 xt. So the same applies to the right hand side. You are going to have theta 1 b capital letter theta 1 b to the power 12, then zt. This is our process in backshift operator. Okay, so you can just write this one as, it can also be written as 1 minus phi 1 b to the power 12 xt, which is equal to 1 minus theta 1 b 1 minus capital letter theta 1 b to the power 12, then zt. Are we together? So they're the same. You can write it like that. So now, here on the right hand side, you can open the brackets so that you can have a linear equation. So this implies that 1 minus capital letter phi 1 b to the power 12 close brackets xt can also be equivalent to, so you open the bracket, so 1 multiplied by 1 multiplied by big theta 1 and so on. So you're going to get something like this: 1 minus capital letter theta 1 b to the power 12. Okay, then again minus theta 1 b, then plus theta 1 capital letter theta 1 b to the power 12. Okay, then close the brackets, then zt. So this is our Sarma 011112 in backshift operator. So you can write it in a normal way, in other words, in xt, xt minus 1, xt minus 2, and so on. So you have to know this, how to write it in backshift operator in a normal way, and then in the form of Sarma 01, 11, and 12. And all this stuff. So in this case, if you just want to write it in a normal way, it's going to be xt minus big phi 1 xt minus 12 on the left hand side, which is equivalent to, on the right hand side, you're going to have zt, I don't have a space here, minus capital letter theta 1 zt minus 12 minus theta 1 zt minus 1 plus theta 1 capital letter theta 1 zt. This one is zt minus 30. You didn't tell me this one. It's 13. Remember, it's B power 12 and B. Okay, so that is why it's 13 there. Correct that. So ZT minus 13. So this is the normal way of writing SARMA 011112. Any question?
Don't move, sir. We are still copying.
Okay, I get it. So this is how you write SARMA 011112. So I'll give you another scenario, another example, so that you can follow that. Yes.
On that, you see that line where you have written with, I think, the black pen. The second line with the red pen. You see it? Hey, sir, can you please explain that line again when you were doing the backshift operator? I don't understand it very well.
Okay, it's the third step from the bottom.
Yeah, actually, just explain the first red line there. After that black line, where you said for PB0. That.
Oh, okay. I suppose you are referring to this one, isn't it?
Yeah, that one
So,
and that one.
or the one above it. Okay. So it will take me to the beginning, because now I can just start from the middle. You won't understand. So let me start from the beginning there. I'm saying, I'm giving you a scenario, just an example, where we have got P equal to 0, okay? Capital letter P equal to 1, small letter q equal to 1, capital letter Q equal to 1, and our S equal to 12. Okay. So when we try to include that, remember we have got SARMA, which is this one. We've got SARMA PQ, PQS, which is our general. Okay. So now in this case, because they told us our P equal to 0, okay, our P equal to 0, which is this one here. Our P equal to 0 and our
Sir,
Q equal to 1.
before you go
Yes.
further, sir. Will we given that information that P equals to 0, P equals to 1, or is just a general formula or something?
You can be given. After being given, you must know how to use this general one.
Oh, okay, no
Or
problem.
sometimes they don't give you those P equal to 0, P equal to 1. They just give you what? This one as it is. You see this one? SARMA. They just give you SARMA 0111. And they said, write it in backshift operator. In other words, write it in this form. Or instead of that, they just give you the big shift operator process. They want you to come up with this one, SARMA. So you have to know those things. Or they just give you a backshift operator, which is this one, and they want you to write it in a normal way, xt minus 1, which is this one. So you have to know how to play around with those things. So you still want me to explain?
I think it's fine. So, okay, can I ask something? The last one.
Yes.
I'm not sure whether you will see the line. You see the line where you converted to bed shift operator. I think after the black line is the second line where you put the asterisk, the second line, you see it. So say, will I be correct if I say always, if I just say or like if you can check, like if there's that equal sign on the left side, will I be correct if I just say 1 minus that process and I check what it is based on xt? I mean, like when I'm writing the backsheet operator, When I go to the right side, I also say 1 minus that process, as you can see, is fire 1B. And I say 1 minus the other one. Will I be correct, or it depend on some things? Because
I didn't get you.
okay,
Can you
so let's
repeat
say
again?
that I guess that when we're doing with the backsheet operator, we take the common factor there and we leave it to 1 minus whatever left, and we say the process depend on xt. So
Yes, I see.
on this one, we're just having big fire 1b to the power 12 xt, meaning there's no
Yeah.
common factor of anything. So I'm asking, I will be correct if I say 1 minus whatever that I have, and I close the bracket and I check whether the process depend on xt, and I will write xt if it's yes. If it's zt, I will write zt.
Yeah, I think there is no harm on that. I think it's the same thing.
Okay, now it's fine.
Okay.
Thank you.
Sure. So let me just give you another example, maybe to understand this better. Let me just give you another scenario so that you can understand this. Can I go to the next page?
Yes, sir.
Okay, then.
Yes, sir.
Okay, let's say now you have got P equal to 1, and then Q equal to 0. Okay. And capital letter P equal to 0. Okay. And capital letter Q equal to 1. And then our S again still equal to 12. Okay, let's say you are using this one. The first thing to do is to write it in this way, Sarma. So we're going to write Sarma. P is going to be 1, Q is 0. Then for seasonal, P is 0, and then Q is 1, then S 12. So this is the first step. Okay, so now you just want to write this one in backsheet operator now. So you are going to have phi 1 B for non-seasonal, but for seasonal, because P is 0 there, so you don't have it. Okay, instead you are going to have xt. You get that? So now for the right hand side, for the moving average, you are going to have Q is 0, so you don't have theta QB, you don't have it, but you have the 1 for the seasonal, which is 1 there. So you are going to have capital letter theta 1 B to the power 12, then ZT. So this is the one. So which you can write it as 1 minus phi 1B xt, which is equal to 1 minus capital letter theta 1 B to the power 12, then ZT. Okay. So this is in backshift operator. So if you just want to write it in a normal way, so you can continue and write xt minus phi 1 xt minus 1, which is equal to 30 capital letter theta 1 ZT minus 1. So this is the process that we've been looking for. Okay, that's SARMA now. So I think now you understand moving from ARMA to SARMA. Okay. So if we understood this one, so we can just go back to ARMA again while moving to what? To ARIMA. So this one is it's a stationary process. So now I just want to show you the scenario where we have the non-stationary process. How do we go about it? There is somebody who just unmute the mic and is making noise. Okay, thank you. I was saying we had a stationary process, which is ARMA. Then we include the seasonality to become SARMA. Then we get a process like this. The process that we've been dealing with were stationary processes. So now let's go to the case where we have the non-stationary process. You know that if the process is not stationary, you have to apply one of the transformation methods. For example, in our case, we normally apply differencing, isn't it? So we're going to do that. Okay, now let's start again from the ARMA process and show you how do we do that. Let me just use this one. Remember ARMA, it's too fine. Remember ARMA, PQ, it's a stationary process, this one. It's given by phi P B xt, isn't it? Which is equal to theta Q B ZT. This is the ARMA process. So now, from this process, if we just assume that it's not stationary, we have to add another part called differencing. So immediately when you add differencing, so this part here, the autoregressive part, you are going to have phi PB, okay? Then because it's not stationary, you have to add differencing, which is what? 1 minus B to the power D. So in other words, we're generalizing it. The differencing is generalized as D. You differentiate it 1, 2, 3, up to D times. Okay, so that is why I included 1 minus B to the power D. That is the differencing part. Okay, then xt. Okay, which is equivalent to theta Q B ZT. If you can check, on the right hand side, I didn't introduce any differencing part. Is there anyone who can tell me why? We just introduced this differencing part on the left hand side, but on the right hand side we don't have it. Is there anyone who's having any idea why we did like that?
Because moving
because MA is always stationary.
Definitely, thank you very much. Because that other part on the right hand side is a moving average, and a moving average is always stationary. So there's no need to differentiate it. So that is why we're differentiating the left hand side, because it's the autoregressive part. And we realize that it's not what? It's not stationary. So that is why we included that part of differentiating. Okay, you get it very well. So now, coming back to this part now, remember it was ARMA. Because the process was what? Was stationary. So in this part, because this process is not stationary, so ARMA now becomes ARIMA. This one is going to be ARIMA. So ARIMA what? ARIMA of P, that P is of order of autoregressive process. And because we have difference there, how many times? D times. You have to include D there. And then you have to include the part that the parameter or the moving average part there, which is Q. You see now, we moved from ARMA PQ, which is this one, to ARIMA PDQ. The part that we included there, if you check, we included this I here. Call it integrated part. So ARIMA, when you read it, it's autoregressive integrated moving average. So that is why I'm saying that I stand for the integrated part. So ARIMA stands for autoregressive integrated moving average. So the parts within the brackets there, those are the orders of autoregressive, which is P, and the order of integrated part, which is D, meaning differencing, and the order of a moving average, which is a Q. Then later it produces 5PB 1 minus B to the power dxt, which is equal to theta Q B ZT. Are we together? So now, let's say for argument's sake, our P equal to 0 and our D equal to 1. What does that mean? It means that we difference the process only once and the process becomes stationary. So we difference it only once. So that is why we say D is equal to 1. Then, and our Q equal to 1. So P equal to 0 simply means that we don't have an autoregressive process. And D equal to 1 simply means that we difference the process only once. And Q equal to 1 is simply means that we have a moving average of order 1. So how do we write this one now? So you are going to have, we don't have 5 something. So we are going to have 1 minus B to the power 1. Or you can just leave it as 1 minus B. We know that there is a order 1 there that we have differenced. Then xt. Are we together? It's on the left hand side. So on the right hand side, it's a moving average of order 1, which is the same as theta 1 B ZT. So this one now becomes what? Because our P is 0, D is 1, Q equal to 1. So we can call it ARIMA 0, 1, 1. Are we together? It's autoregressive. We don't have it. Difference only one times, and then moving average of order 1. So if you don't want to write it like this, you can write it as what? You can tell me. If you don't want to write it as ARIMA 011, you can write it as what?
IMA 11.
IMA 11. Thank you very much. So the same thing. Sorry. IMA 11. Sorry, 11. It's ARIMA 011 or IMA 11. Any question before we move on? Okay, if you get this one, so let me just give you another scenario so that you can understand it better. You're still writing?
You can continue, sir.
Okay, thank you very much. Let me just move on. Now, let's say our P is equal to 1. Why can't I put 2 now? Because I've used 1 for quite some time. Let me just say P equal to 2. Okay. And then G, let's say equal to 1. And Q equal to 2. Okay. Obviously, you are going to have what? ARIMA. Because you have already differenced there. Takes you to ARIMA. ARIMA what? ARIMA 2, 1, 2. You see that one? It's autoregressive of order 2 differenced only once, and a moving average of order 2. So how do you write this? Remember, it's autoregressive of order 2. How do you write autoregressive of order 2? So you're going to have phi 1 b phi 2 b squared xt on the left hand side. So on the right hand side, you're going to have theta 1b minus or plus whatever you can put it there, theta 2b squared zt, which you can also write it as 1 minus phi 1 b 1 minus phi 2 b squared xt, which is also the same as 1 minus theta 1b 1 minus theta 2b squared then zt. Are we together? So you can also go on and open the brackets, all those stuff. But I wanted you to know that autoregressive of order 2, moving average of order 2, how do you write it? It's like that. So, but if you just want to write it in what? In normal way, so you have to open the brackets first, multiply each, do the same on the right hand side, open the brackets, open everything, multiply everything. So let's start with this one on the left hand side so that you can understand what we're talking about. It's going to be 1 minus phi 1 phi 2 b squared, isn't it? Then minus phi 1 b, then plus phi 1 phi 2 b to the power 3, isn't it? Then xt, which is equivalent to 1 minus theta 2 b squared minus theta 1b plus theta 1 theta 2 b to the power 3, then zt. Are we still together? Then it's in backsheet operator now, like this. Okay, so if you want to write it in a normal way, so we're going to have what? Xt, okay, then minus phi 1 xt minus 1 minus phi 2 xt minus 2 plus phi 1 phi 2 xt minus 3, which is equivalent to moving average zt minus theta 1 zt minus 1 minus theta 2 zt minus 2 plus theta 1 theta 2 zt minus 3. That is our process. That is our ARIMA 212. Any question?
Sir,
Yes.
when you were defining the ARIMA, can you just try to elaborate what you wrote on the first lab there?
On the first line.
Yes, sir.
Okay, let me start. So I'm saying we take a scenario where we have P equal to 2. In other words, we've got autoregressive of order 2. That is why we're saying P equal to 2. We're saying that we've got an autoregressive of order 2. That's why I said P equal to 2. And we realize that, okay, we differentiate only how many times? Once. No. You see what is happening here?
Sir,
We forgot the
when we are
differencing.
differencing, do we do the both
Yeah.
sides or the one side?
Before that, I think we forgot the differencing. Remember, here we difference only once. So in this case, we dealt with the scenario where we didn't difference. In other words, like that, d equal to 0 in this scenario. In other words, we're dealing with ARIMA 202. Because if you check here, we don't have a differencing part. I forgot about that. So this one is when we didn't difference. In other words, in this case, we are dealing with P equal to 2, D equal to 0. Yeah. And then Q equal to 2. It's this one. It's this part. You see that? But if D equal to 1, so you have to introduce the differencing part, for which we have already forgotten here. It's not there. So you have to include it. You get what I'm saying? So in other words, for ARIMA 212, this one is ARIMA 202. So now, if it's ARIMA 212, you're going to have again parameter phi1 b phi2 b squared. Okay, but we have a differencing which is 1 there. Differencing which is 1, so you're going to have 1 minus b to the power 1, or we can just leave it as it is, then xt. So we forgot to include that 1 minus b. And there is no one who has noticed that. So we forgot to include this one before.
Sir,
Yes.
that's why we are asking you, because we see these mistakes. And now what I want to understand from you, it's for you to tell me what's happening on this phi 1b and phi 2b squared xt. Try to elaborate what you wrote there, sir.
Yes, but thank you very much for your question, because it makes me to realize that we made a mistake. Thank you very much for that. So to elaborate, don't worry, I will elaborate it for you. Remember, we are taking a scenario where, so let me just finish writing this one before I forgot. So this one now is going to be on the right hand side is going to remain the same, because we know that moving average is always what? Stationary. So theta 2 b squared zt. So let me just elaborate the first one before I come to this one, then that you can understand that one. So here, like I said, I was saying that we forgot d to include the differencing part, because d it was equal to 1. So but in this case we rectify to be d equal to 0. Okay, so that it can make sense there. So d equal to 0, so that it can make sense there. So this one is going to be 0. Don't get confused. It's just because we were dealing with the process where d equal to 0, whereas d is equal to 1, not realizing that we're making mistake. Then later we realized that, okay, we were dealing with d equal to 0 instead of d equal to 1. So that is why now I'm changing d equal to 1 to be d equal to 0, because there were no differencing. So in the second part, the one that is having a star there, this is where we have included the differencing part, which is 1 minus b. So, but however, let me just explain this one where d equal to 0. How did we come up with the final?
Say the product, like you know what I don't understand, specifically the product. Like check there when you wrote that first ARIMA 202. It's phi 1b multiplied by phi 2b squared xt is equal to phi 1b multiplied by phi 2b squared zt. Like, where is this product coming from? Because from the general formula of the autoregressive integrated moving average, it's something different from what you wrote here. Like, what's the idea behind?
Oh, the general formula, the one that we are referring to, is ARMA. Let me just write it down. If I understood well, ARMA, you are referring to this one, ARIMA. The general one is this one, P, D, Q, isn't it? It's what we are referring to. General one is ARIMA PDQ. Okay. So in this case, our P equal to 2, D equal to 0, Q equal to 2. What does that mean? I tried to explain, maybe you didn't get me. I said if P equal to 2, it simply means that we have an autoregressive of order 2. I think you have understand that one. If Q equal to 2, so we have got a moving average of order 2, which I believe you know how to write the autoregressive of order 2 and the moving average of order 2.
Sir, can you please write what I will tell you, like now. I want you to take it from the general formula and write what you have there. It's
Yes,
5.
come up with the
It's 5.
Yeah?
It's 5.
5
of alpha B subscript
5
alpha.
of alpha.
Yes, sir.
Eh? No. Where did you get alpha from now?
5 subscript alpha B.
What are you saying? You are referring to this?
Yes, sir.
Okay, then
B of B. 5 subscript alpha of B, and the difference operator there, an exponent dxt.
What I wrote there, in other words, I can't even remember where I wrote phi alpha. It's either phi p, because why? This p represents the order of autoregressive. Okay. And this one alpha, if you are saying I wrote alpha, so that means I'm referring to the order of autoregressive as alpha. This way I don't get it.
Sir, let me read this statement to you. Maybe you will understand me. They are saying the AREMA process ST is said to be an autoregressive integrated moving average process. AREMA of P, D, and Q. If it D difference.
Remember, it's very difficult to understand you while you are reading it as theoretical. Can you refer me to where you are reading it from?
Using this other book, say. There is a book.
You see now, which book?
Sir.
Remember, I told you that there are the books, these books of time series, they are different. There are those who are using different
for multivariate and univariate time series books.
Yeah, so that means you were not there when I started teaching this time series. I told you.
No, I was there, sir.
Okay, let me just remind you again. I said in a time series process, other books, it's when I was referring to the white noise. Other books, they use ZT as a white noise. Others, they use AT as a white noise. Others, WT, and so on. Then I said, in our case, we are going to use ZT as a white noise. So don't be confused with other books that are using AT and all those stuff. Because if you try to combine the two, you will end up being confused. So it's better to follow the same things that you are using. Or if you are using the parameter, if we were saying autoregressive of order P, we're using P as the order of autoregressive. Just use that one. Otherwise, if you just combine with another one, in my case, I won't understand what you're referring to.
Sir, please
You
write
asked
the
if I
general
do a
model.
book.
Sir.
Sir, please write the general model. I want to show you something. Please write the general model and the formula.
The general model for?
Sir, can we have a break?
Guys, I need one person at a time. I can't hear you if you are talking as a group. One person, so that I can
we have a
understand.
break, sir?
Oh, you're talking about the break.
Yeah.
Yes, yes, I can have a break. I can have a break.
Okay,
I can
sir.
see that.
Now it's too late for a
20
break.
minutes.
Too
I
late.
say let's just finish.
Please finish, sir. Sir, may you please
Yes.
continue with Arima 212, please?
Thank you very much.
Say, explain there.
Let me just go back, isn't it? I was explaining the one with red color. So I was explaining that if they gave you,
Please write the general model. We don't understand this thing you wrote here. Please write the general model. We want to show you where we don't understand. Write the general model so that we show you where we are not.
yes, the general model for what?
For the ARIMA.
Oh, okay. I wrote it there, so I can just show you. This is the general model for ARIMA.
Yes. You see the model, okay. Check the model there, say, and go check what you wrote for us there as an example.
You are referring to
Yes,
this one?
yes. What is happening there, sir? We don't understand when we are checking the general model and what you wrote there. We see something different. Can you please explain to us what is happening?
Yes. You know why is it different? Here for the general one, 5p. Here you have got 5p. B. So in other words, is the order of autoregressive. We are generalizing it. We are taking all of them. 1, 2, 3, 4, 5 up to p. Okay, so that is why we are having something like this. So that is why at the end of the day I said this one is the same as 1 minus phi 1, b minus phi 2, b squared, and so on. This is the order of p. So if we have got, if p is equal to 2, in other words, it's autoregressive of order 2. So we are going to have these two. Okay, so that is why here, sorry. So that is why here I'm having these two, which is this one and this one. So they're not the same.
But it's a polynomial. It's a
Sir.
polynomial, and in that case, it's a product. Like
Isn't
I
it?
don't understand.
It's a product to the
So
point where you
when you
answer that
try to
one.
extend this one, it's going to give you the same thing. It's
No,
going to take
sir.
you here. It's going to take you here. This is the same thing. It's the same thing. It's just because we started here, but it's the same thing. It's phi 1b,
No, sir.
or maybe
Sir.
I was supposed to start
Let's
with
say
1
if
minus phi 1b, phi 2b squared. It's not the same.
Say,
It's not this one.
why not if like we are doing the back shift for 5pb, we're starting at 1, right? It will be 1 plus phi 1b minus phi 2b squared. Then after that we multiply with the differencing, which is 1 minus db. Then when we like expand the thing, we don't have the phi 1 phi 2.
If you have what? Phi 1, phi 1, phi 2 is coming from the order. There are two. That is why we're having phi 1 and phi 2. It's the order because p is equal to 2 there. If p equal to 1, you can have phi 1 and phi 2. If p is equal to 3, you are going to have phi 1, phi 2, and phi 3 because of the order.
If P is 1, are we having 1 minus phi 1b, right?
Yes.
Then if it's P is 2, it's 1 minus phi 1b minus phi 2b squared, right?
Yes.
Then when we multiply that with the differencing part, how are we going to get the phi 1, phi 2?
So for this one, isn't that we're dealing with, we don't have the differencing here. We don't have the differencing. That is why I said it's 0 there. D is 0. So that is why we don't have the differencing part. The one that we are having the differencing part is this one. Here, down here. It's the one that is having the differencing part.
Sir,
So this one, the red one, doesn't have it.
Sir, can we see you in your office? Like, are you in your office
Yes.
like now? We will come
Right
there.
now.
You can continue with this thing, but we will come there.
Yes, but you have to check the consultation times. You are not supposed to just come. No, you will consult on this one. There's no problem, so that you can understand it better. So I don't know whether each and every one is having the same problem. Guys,
we are confused, sir.
you are confused, ne? I don't know how can I explain this. Can I explain this one where we have the differencing, because it's the one that we were talking about, the last part here.
Yes, sir. Maybe we'll understand.
And then you will compare with the other one and see where lies the difference. Okay. Let's go to this one. Maybe you will understand it later. Okay, let me just go down. We're saying we've got ARIMA 211. Okay, 212, sorry. Okay. So in other words, P equal to 2, Q equal to 2, and D is 1. So you're going to have the phi of 1b phi 2b squared. Then 1 minus b, then xt, which is equal to what? Theta 1b, big theta 1b squared. Then zt, isn't it? So now, this, I said, is the same as 1 minus phi 1 b minus phi 2 b squared.
So, sir, what I want to understand here, we are taking it from the seasonal ARMA model.
You can't take it from the seasonal, because this one is not a seasonal.
So if you
It's a
don't take it
non-seasonal
from
model.
the seasonal, you're confusing us. Like now I'm confused what you are doing there, sir. The first part, the thing, your second step, is correct, but the first step, how did you manage to write that one? Try to elaborate on that one.
So why do you have the
theta,
Why do you have capital
theta there, say?
Capital what?
Theta.
Capital theta.
Oh yes, yeah. That one I get you. It's small letter, sorry. This is a small letter, the 2. Sorry for that. So you're saying, how did I get to this 2 part, isn't it? Is what you're saying? This one.
The first one is when you write AREMA 2 1 2. The first step, how did you get that phi 1b phi 2b squared?
It's what I'm explaining. I'm saying it's phi 1 and phi 2 because it's the autoregressive of order 2. So you're supposed to have phi 1 and phi 2 because it's the autoregressive of order 2, which is this one. Okay? It's different from when you have got only P equal to 1. In other words, you are going to have only phi 1. It's autoregressive of order 1. In this case, P is equal to 2, meaning that it's autoregressive of order 2. Immediately when you have autoregressive of order 2, that means you are going to have phi 1 and phi 2. So that is why we are having phi 1 and phi 2 there. But because it's a backshift operator, immediately when you write phi 2, it's B squared.
Okay, so let me say, let's write it this way. Let's say phi of B, subscript B of P.
Subscript. It's not a subscript B, that one.
But say, I'm saying phi subscript P of B.
Phi P B, like this.
And the different operator exponent D.
Like this.
No, sir, I'm saying the difference operator. We multiply what we have with the difference operator D. I would.
What are you saying now? We are multiplying by G, like this.
I'm saying, oh, that triangle, that triangle which is
this one.
Yeah.
Like this.
Yes, sir. Yeah.
This one is the same as 1 minus B. It's like this.
Yeah,
They
yeah.
say.
That's what I want you to write there. I want you to write that what you wrote now on the formula. I want you to take it
I
from
wrote
there.
it. This is the one. This is here. This is the one. But you
Write
don't
what
have D.
you wrote that one. It's not from what I am trying for you to write what I have here. I want you to write what I have here so that you can explain, because it seems like these people, they understand, but myself, I don't understand what you are writing. So
what you're saying is this one.
Yeah, and also multiply that one by xt.
Okay. Wait. By xt, yes.
Equals to the phi of
phi
q.
or theta.
You can say theta of q.
Can't say phi. It can't be phi, both of them.
Of b. zt. Try to explain from this general formula and try to write this step, the first step which you have there. Maybe I will understand.
You want me to explain this general one?
Say.
Yes.
Okay.
Say.
This someone is saying say.
Say,
Okay.
before you explain, ne? The thing that he's asking, ne, I wanna know whatever you wrote there, doesn't it mean or if it was Arima 3, ne? Then you would start the whole equation with alpha 1 b alpha 1 b b to the power of 1. What's that?
You are referring to phi.
Phi, yes, phi
Yeah.
1 again. Then b, okay, I don't see what you wrote there. And then phi 2 b squared, and then phi 3 b cubed, isn't it?
Yes.
Then if it goes up to 4, you just extend to phi 4 b 4.
Yes, like that. Yes.
Yes.
What is happening?
And so what's the confusion here?
Those ones. Where did you get those ones? The phi 1b, phi 2b, phi 3b.
Where did you get them from?
Yes.
From the order of autoregressive, yeah.
But
coming from P.
Here it's theta p. You just say the phi of 3, the phi of 2 b into 1 minus b, then exponent 1, then xt. Then when we like expand the phi of 3, it will be 1 minus phi 1b minus phi 2b, which is the order of 2. Isn't it doing it that way? Because like if it's like this, say now I'm confused.
Hi. No, it's the way you understand it, but I'm explaining the way it's supposed to be. So in general one, like what she was asking the lady before, she was saying if it's p equal to 3, it's phi 1 b, phi 2 b squared, phi 3 b cubed. Okay. If it's p equal to 4, it's phi 1 b, phi 2 b squared, phi 3b cube, phi 4 b to the power 4. This is how it's supposed to be. Then from there you included that one minus something, then you try to expand it. This is how it's supposed to be.
Yes, sir. Can we finish the example, sir?
Yes. Now it's confusing. I don't know where to start. Okay, so I have to delete this one. So the problem is when we were busy doing the example, somebody just intervene and then we go back. So I think it's better to wait for me to finish the examples, then that you can ask the question. Then you compare with the other one. Okay, I was writing this one. Okay, it's fine. It's like that one. So this one. So step number 2. So it's what I'm saying. You can just phi 1b can also be written as 1. Phi 1b 1 minus phi 2 1 minus b xt. Then 1 minus theta 1b. 1 minus theta 2b squared.
Say, right now, what are you writing there? Is it still the same thing?
Yes, the one on the, yes, we are just trying to expand the one above there.
Or you are solving further? Okay.
Then that this is what we have. Actually, phi 1b, I just expanded this as 1 minus phi 1b. Then phi 2b squared is 1 minus that one, and so on. So are we together? So maybe the problem is the parameters. This one, if you will be doing the work using the real numbers, maybe you will understand it better. But the issue is, at the end of the day, you are going to have zt minus 1, zt minus 2, to show that is autoregressive of order 2, like what we have here. Can I go back? You see here. X minus 2, like that one, like that one, like that one. Are you still there?
Yes.
Yes.
Yes. Yes, sir.
Okay. So now I think you can just expand this one again a little bit. Let's start with this one, then forget about the differencing part. So we're going to have 1 minus phi 2b squared minus phi 1b plus phi 1 phi 2b to the power 3 then 1 minus b xt, then 1 minus theta 1, let's say 1 minus theta 2 b squared minus what? Oh, theta 1b plus theta 1 theta 2 b to the power 3, then multiply by zt. Okay. Then from there, because this is a differencing. Normally for the differencing, because it's a differencing part, it's not necessary just to multiply through there. So in backshift operator, you can just leave it like that. This one represents the differencing. This one is the order of autoregressive, and this one is the order of moving average. And remember, you know why now we are having 3 here? It's like zt minus 3. Here it's like xt minus 3. Because of the differencing part. Immediately when you difference it, it takes you to another level. You are no longer differencing the same process. You difference another new process. So that is why at the end of the day, we are going to have a new process here because of the differencing part there. So I think we can just go to example on page.
Say,
Yes.
so
Page
are we
36.
done expanding?
Yeah, this is in backshift operator, this one.
All right. Thank you.
So now let's go to the exercise so that you can understand it better. On page 36 for the lecture notes, they are in backshift operator there. Oh, let me just write them down if you don't have them. Can I go to the next page? Can I continue to the next one?
Yes, sir.
Yes.
Okay. Okay, exercise 4.11, 4.11, 4.11, sorry. Page 36. It says identify the following models. Identify the following models. Okay, number 1, 1 minus 0,8, B, 1 minus B, xt, then zt, 1 minus B, xt, which is equal to 1 minus 0,7, 5b. Then Z3. The last one. 1 minus 0.9 b 1 minus b xt, which is equal to 1 minus 0.5 b zt. You can see that. So they want us to identify the model. In other words, they want you to find p.
This one.
Come again? I didn't hear. Come again. Okay. So anyway, they want you to identify the model in this way. It's like find ARIMA PDQ. Sorry, it's like that. There's no seasonality there. Yeah, it's ARIMA PDQ. In other words, you have to find the order of P, the order of D, and the order of Q. So I think our time is up. Can you go and try to solve that one? We'll talk about it on Friday.
Okay. So is there gonna be a special quiz?
Come again?
Is there gonna be a special quiz?
You can't ask me about the quiz because I have not yet started marking. Why are you asking about the special one? You didn't write.
Yeah, I'm just asking. It's important.
No, just wait for me before. You can't ask now before I mark them. I'll mark them, then we're taking it from there.
But it's important.
It's important. For me, I don't understand why are you asking it.
Say.
What about if you go to
Say. Akiri, we saw there was only chapter 2, so we thought maybe there's gonna be special and there'll be chapter 1 and 3 included as well.
When we say there is chapter 1, 2, 3, doesn't mean that we're going to ask everything.
Mara, you robbed us. Say.
It's not like that. Remember, I told you that for a quiz, you consider chapter 1, 2, 3. The same applies to a test. It's chapter 1, 2, 3. Maybe something that are not there, they are there on the test. I don't know.
You know, say they are there. All right, no problem.
So,
yeah?
When are we writing the test 1?
When are you writing test 1? The timetable is not yet out, but it's somewhere April.
Oh, so the scope is always,
yes, the same. Always the same. I won't change it.
1, 2, 3.
Chapter 1, 2, 3.
Right. But you must say especially 2 or especially 3.
Say, can you please use that tutorial time to give us a correction of
before I mark?
Yeah.
Say we don't want tutorials today. We
want to have tutorial today, but what I'm asking you, can I give you the solution before I mark? It's going to be good for you?
No.
It's not.
No.
First mark, then give us.
Definitely supposed to be like that.
I say it's good. The marks won't change. It's good, say.
But you are going to have a problem because now you thought maybe you got total.
Yeah, give
it's not gonna happen.
Huh?
Send to her alone.
No.
We don't want
Let me just
stress.